Hello friends, good morning everyone. Today we will discuss the concept of insertion and deletion operation in queue. So in the last session or in the last class or in the last video, we have seen that what is the stack, how we are going to represent that stack, or what are the stack instructions. In that stack will be operated in two form. First one is the push, another one is the pop, and also we are discussing about instructions of that stack, that may be LXISP, push RP and pop RP. So that is the push in decrement, pop in increment. So that is also we have seen in the last class with respect to some examples, and also we have seen that queue. So what is the queue? First in first out, that is the PIPO. It is a linear list of elements, insertion at one end and deletion at another end. So also if you want to represent or if you want to operate that one, you are going to represent in the two way. One is for what? Array, and the other one is for what? Linked list. So array is the set of some elements you can represent very easily. Okay, and linked list is the connection. It is a set of two connections. Okay, node by node, one node to the another node. So that is the linked list. So next we will discuss how you are going to use queue by using insertion and deletion operations in queue. Okay, so first we will discuss the one general example of queue. So how you are going to represent that queue. So again, if you want to represent in a queue, so first take one queue. So in that you have to set some elements. Okay, so in the first side or in the left side you have to use the front deletion, and at the end of the side or the right side you have to use the rear insertion. Okay, so in the front end you have to delete, and in the rear side you have to insert that queue one by one by using these elements. Suppose consider queue size should be 6. Okay, and write that one 1, 2, 3, 4, 5 and 6. So if you want to delete that one, you have to use A as a front, and rear you have to use for what? Insertion. Okay, so if you want to represent that one, so E is the insertion and A is the front. Okay, so if I want to use another variable in that empty locations, for consider D. So if you want to add or if you want to insert that one, D it is my element. So you can say that one as my item. So item equal to D I can write. Okay, so we will discuss in a detailed way. So how we are going to use this one? So first one is the insertion. Okay, so if I want to add my D, okay, so if I want to add my D, so that time I will write rear equal to, so from rear side or from the rear end I will add my empty element. Okay, so consider rear equal to rear plus 1 because I want to add one more item. So that purpose I can write like this way: Q of rear is equal to the item. Means what? In rear you are having what? Some element, that is the E. Consider that one, assume that one E. If I want to one more value, so that time I will write rear is equal to rear plus 1. Then I will write Q of rear. Means what? Q of rear is equal to item. So means what? In that Q of rear is equal to item means what? Item value should be what? D. Okay, so this is the first step of. So there are conditions if you want to insert that one. Consider one queue A, B, C, D, E, F, G. So first condition is what? If front is equal to 1, real is equal to n, so print overflow return. Second condition, if front is equal to null, set front is equal to 1, rear is equal to 1. So these are the conditions which are related to what? In insertion part. So in this concept we will write some algorithm. By using this algorithm we will discuss how we are going to write these conditions. Okay, so first condition is the what? If front is equal to 1 and rear is equal to n, So print overflow return. Second condition, null condition, and you have to, one is the null, another one is the some value. So if front is equal to null, set front is equal to 1 and rear is equal to 1. You have to write algorithm. By using this algorithm only, you can understand very easily how you are going to write that conditions. By insertion algorithm, what it says, insert q, first you have to take the q, comma n, front, rear and item. Q, you have to take one q first, then you have to decide that size, that is the n, and in that q and size you have to decide the front and rear, and you have to take the one more value, that is the item. Okay, that is the variable. Suppose we have a queue with an element. Suppose we have a queue with an element and we have to insert an element stored in item variable. So you have to insert that stored in item variable. So first step is what? In algorithm, if front is equal to 1, if front is equal to 1 and rear is equal to n, that is queue is full. If the queue is full, means what? You have taken one example, A, B, C, D, E, F, G. So this is the first, it is a full. So your queue is full, you are not having any empty value in that location. So that's why in first step, you can write, if it is a queue is full, if front is equal to 1 and rear is equal to n, if the queue is full, then you can write overflow and return. Write overflow and return. You can observe the diagram, A, B, C, D, E, F, G. So this queue will be totally full. So then you can write the print overflow return. You cannot do anything here. Okay. So second step, find new value of rear. Means what? If front is equal to null, that is if the queue is empty, then you can write set front is equal to 1 and rear is equal to 1, else rear is equal to rear plus 1. So this is the second step, find new value of rear. If front is equal to null, is queue is empty. Means what? If the queue is empty. So this is the part. Queue is the empty. So these are the queue is the empty. Then you can write if front is equal to none, set front is equal to 1 and rear is equal to 1. The meaning is what? If front is equal to null, his queue is empty. Here if the queue is full, second step, if the queue is empty. But you have to set some value. So that's why you can take, I will write that A in this diagram. I will write that A. Already it is a null, but I will write that A. So that is the front. So that's why I will write if front is equal to null, is queue empty, set front is equal to 1, rear is equal to 1, else rear is equal to rear plus 1. I want to add one more value in that empty position. Okay. So that rear is equal to rear plus 1. So already rear is equal to what? That front is equal to null, is queue is empty. So set front is equal to 1, rear is equal to 1. So that's why else rear is equal to rear plus 1. So set q of rear is equal to item. Means what? Again I want to add that item into that new variable. So that's why I will take one variable, that is the item. Set q of rear is equal to item. Then you can exit. So this is the insertion by using q operations. So this is the algorithm you can follow. Okay, so this is a very easily you can understand algorithm. So next we will discuss deletion operation. So in deletion operation, again these are the values. Front is the A, B is the rear. Consider this one example. Then you can write item is equal to, you can take first q. So in that q you have to take the front and rear. So then you can take the item is equal to A, q of front. So then I want to delete that A. Okay, so that's why I am taking that cross mark. So then I can write front is equal to front plus 1, because I want to move towards the B value. So that's why I will write front is equal to front plus 1. Means what? After that A is the deletion, I will move towards the what? B. So next you can take another q. Next you can take another q, that is the null. Okay, so these are the three operations. So how we are going to write these algorithms? You can observe this one first. So by using algorithm only you can understand very easily. So that's why you have to write the algorithm for delete operation. So first you can take one q. So that's why I'm going to return that one q. Then n number of size, then front and rear and item. So this algorithm delete an element from a queue and assign it to the variable item. Okay, so first if front is equal to null, queue is empty. So first consider your queue is the empty. So then I will write if front is equal to null. So that front is equal to null. Then write underflow and return. Then write underflow and return. So this is what your first underflow and return. So if front is equal to null, so this is the your queue is totally empty. Then directly I will write if front is equal to null underflow exit, because you don't have any value in that queue. So that's why I will write underflow exit. Second one, set item is equal to queue, that is the front. Set item is equal to queue, that is the front. So this is the what first you are having what A. So that is the one atom in that you are having one in that queue. You are having what A as the A and some null. Okay. So that is the new value of that item. So then I will write set item is equal to queue of front. So in that front you are having what A. Okay. So then if you want to find the new variable of front, means what? If front is equal to rear, queue has only one element. If front is equal to rear, queue has only one element. Set front is equal to null and rear is equal to null, else front is equal to front plus 1 exit. So this is the algorithm. Means what? You can observe in the diagram. If front is equal to null, first is the underflow exit, second one item, so that is the set item, that is item queue of front, that is front is equal to rear is equal to null. If you want to add one more, that is the A and B, after the A is the deletion, you can use the one more, that's why you can write front is equal to front plus 1. So this is also one of the thing you can observe. Set item is equal to queue, that is front, find new variable of front, if front is equal to rear, queue has only one element. Set front is equal to null and rear is equal to null, else front is equal to front plus 1. So first you have to set the front is equal to null and rear is equal to null. If you want to add one more new variable, then we can write front is equal to front plus 1, then exit. So these are the concept comes under what? Queue operation by using insertion and deletion. So it is a very important part. These are the basic things you should easily understand step by step. Okay. So next we will discuss the subroutine. So what is the subroutine? So first of all, this subroutine is a small program written and stored separately. Written also and stored separately, and it can be called whenever required. Means what? If you want to do some, if you are writing some particular program, okay, so in that you are doing some functions and pointers, okay. So in that you can write anywhere whenever you are required. If you want to call that one or if you want to return that program, so that purpose you have to use for what? Subroutine. So that's why it is called as a small program written and stored separately, and it can be called whenever required. It is also called as a block of instruction which carries out specific and well-defined task. If you want to carry that subroutine by using that program, so it may be well-defined task, or it is a subprogram or a function in the main program that performs specific tasks. So whenever you are going to write some main program, so in that main program only you can write particular subroutine call or return values. So we'll discuss by using one example. Okay. So next, subroutine call and return. How we are going to use? So first step is you can observe the one memory diagram. Okay. So that is the main memory. So in that I will mark as a instruction 1, that is the 1, instruction 2, instruction 3. I will directly write in the fourth location call subroutine A of that 100 value. So directly I am going to writing call subroutine A is the 100 of that value I want. Okay, so how we are going to find out that one? Means what? That instruction 4, I want to call my value should be what? 100. Means what? I want to search my 100 of that value in that fourth position. So then how we are going to use that one? So that purpose you have to return one memory diagram, main memory diagram. So you need one memory stack. Okay, and also what? Top of the stack, that is the stack pointer. So first in subroutine call and return, during the execution of the main program, a subroutine may be called at various points in the main programs. So what is the meaning of this one? During the execution of the main program, you are having what? One main program, instruction 1, instruction 2, instruction 3, instruction 4, whatever it may be, instruction 5. A subroutine may be called at various points in the main program. You can call anywhere whenever required. So like that, I will call that in my fourth position, call subroutine A of 100. So that is the meaning of first point. Second point, a call subroutine instruction consists of an operation code along with an address that specify the beginning address of subroutine. A call subroutine instruction consists of an operation code along with address that specify the beginning address of the subroutine. Means what? It starts from instruction 1, instruction 2, instruction 3, but it will start with what? That operation code of that instruction 4, that is the A. Okay, so whenever if you want to call that 100, so that comes from, it will find out the specific address of that fourth location of that 100 value. Okay, but if you want to start again, so this main memory location should be again start from what? That's with respect to memory stack. Again it will coming back to the fourth position, and it will start from what? That address only, specified address only. This instruction is executed by performing two operations. First one is the address of next instruction is stored in register stack or memory stack. So that is the program counter. And second one is the program counter is loaded with the starting address of the subroutine. The program counter is loaded with the starting address of the subroutine. And last one is the last instruction from the subroutine causes a return to the address stored in the stack. Means what? So suppose I want to start my address with the program counter 5, instruction number 5, but already I was given my call subroutine should be what? A is equal to 100. I will find out, but it will not give the direct value of that call subroutine directly, because it will take first next instruction, then I will write here 100 of that. First I will store my value should be in program counter. Okay, so whenever I required, I will use my stack pointer. So that stack pointer should be stored in the program counter. So I will write my program counter should be what? 100. So then it will say call subroutine A. So in that program counter, your value should be what? 100. Okay. So then again I want to write my next instruction. So that purpose I will move to the what? Instruction number 5. I want to return my value. So again it will coming back to the what? Instruction number 3. Then it will start with what? Call subroutine, then instruction 5, then it will move towards the what? Like this it will operate. So same way I will write 300, 301, 397, 398, 399. So in that program counter, my stack pointer should be what? 400. But instruction number 5 should be what? In that program counter is there. Okay. So after this instruction number 5, it will execute that program counter of that 100. So then it will again coming back to the what? Call subroutine A 100. So that is the top of the stack. So that program counter of the 5 should be what? In that value. So that is the memory stack. So you can write subroutine call list of micro operation, that is the SP. So stack pointer stack minus 1 means what? So whatever that stack pointer is there, so first it will not give your 400 value. So it will give stack pointer of minus 1, that is the 400 minus 1, that is the 399. So in that 399, in that 399 memory of that program counter, you are having what value is the 5. So in that 5 you are having what? 399. Next, memory of that stack pointer should be in program counter. So whatever that 5 is the program counter, that is the 399th position. So program counter starting address of the subroutine. So program counter always starting address of the subroutine means what? It is a 5. Second one, return from subroutine. If you want to return, or first you are call that one subroutine, now you have to write the return from the subroutine. So that is list of micro operation. First you have to write program counter. So store that one by using stack pointer. Memory of that stack pointer should be you have to store in the program counter. Okay, so then you have to increment that one stack pointer plus 1 in that stack pointer. So stack pointer already you are having what in 399, plus you have to add that stack pointer plus 1, that is a 400. So like that you can write stack pointer is equal to stack pointer plus 1. So next, recursive subroutine. A recursive subroutine is a subroutine that calls itself again and again. calls itself again and again. So that is the recursion happening. So thank you. I hope you people will understand this sessions and concept. So in the next class or in the next video or in the next session, we will start with the second chapter. So today I have completed the first chapter. Okay, so thank you very much.